Okay, this is going to be a two-part lesson for section 8.1. We're going to do the first half of it, which is talking about the Pythagorean theorem, and then determining whether some sides of some triangles given to you are in fact Pythagorean triples or not. And then the second half of the lesson, we're going to break into another piece, which is how to classify triangles using the Pythagorean theorem, so that the video isn't super duper long, okay? So we're starting off with Pythagorean theorem, and what you need to know about chapter 8 is that it is consistent to deal with just right triangles. So we are only dealing with right triangles in this chapter. The Pythagorean theorem itself pertains just to right triangles. Okay, right triangles, really important. Right triangles, we know, have a right angle. And so the example off to the side here is a right triangle. So I'm going to put my symbol in the corner, which indicates that it has a 90-degree or a right angle. So this is a right triangle. So in the case of a right triangle, the Pythagorean theorem states this: c squared equals a squared plus b squared. That's the formula you're going to hear repeatedly. The c represents the hypotenuse. Okay, c is always your hypotenuse. Always. Okay? And the other thing you need to know about the fact that it's always the hypotenuse is you also need to know that the hypotenuse is always the side across from your right angle. Across from your right angle. So C is always your hypotenuse, and it's always the side across from the right angle. So let's label our picture. C is this side, hypotenuse. Okay? A and B represent the other two sides. Okay? The other two sides. We call them the legs of the triangle. And it doesn't really matter which one's A or which one's B. Okay? It doesn't really matter which one is A or B. What matters is that those sides are considered the legs of the triangle. So we're going to label those. So this is A, and this is B. And again, these are the two legs of the triangle. All right? So the theorem says that if you take the length of the hypotenuse, so you take the value for C and you square it, and you kind of set it aside, and then you take the values for each of the legs, A and B, and you square their values. So you square A and then you square B, and you add them together, they are always equal to the C side, the hypotenuse side squared. So no matter what, those always are true to be equal to each other. And it works out that way for all Pythagorean theorem right triangles. Okay? So a Pythagorean triple is what we call a set. We're going to work with the triangle in just a minute. So it's the set of non-zero whole numbers. So a set of non-zero whole numbers. So I give you three numbers, A, B, and C, that work or that satisfy the equation. For the Pythagorean theorem. Okay? So it satisfies that equation. So what I'm saying to you is, if I give you a value for A, B, and C, and you plug it into the equation in the appropriate places, you square them, and they equal each other, then you know that you have a right triangle and a Pythagorean triple. So the first example says we have a right triangle that has a hypotenuse of 25. So you just kind of draw out a little rough triangle over here, put your right angle in. Hypotenuse is 25. I know that is always the side across from my right angle. And a leg of 10. find the other leg. So I just threw 10 in place of where A would go, and I threw B over here. If you want to put 10 where B is and then find A, it's the same thing. You're finding one. You have one leg and you're finding the other. So then I'm going to do C squared equals A squared plus B squared. C always represents my hypotenuse, so I'm going to plug in 25 squared equals A, which I plugged in as 10. So 10 squared plus B squared, and now we're just going to solve to figure out how much the other leg is. So 25 times 25 is 625. 10 times 10 is 100 plus B squared. So again, I'm solving for B, so I need to subtract the 100 from both sides so that I can isolate the B squared. I need it by itself over here. 625 minus 100 is 525. So 525. So the question becomes, how do you figure out what B is if, oh boy, my marker's being crazy. How do you figure out what 525 is? I'm going to fix this for you because my marker's stuck and was writing when I didn't want it to be. 525 equals B squared. Okay, so 525 equals B squared. Think back to the last lesson where we were talking about roots, and we said that if you squared a square root, so let's say I had x and under here and I squared it, we said that these two things, squaring something and the square root of something, were inverses, right? And so by squaring a root, we canceled them out and we were left with x. We're going to use that same concept here. We're going to undo a square by square rooting it. So I am going to square root both sides. Square root of B squared, square root of 525. They're inverses, so they cancel, and I get B. And then you can just use your calculator to do the square root of 525, and you're going to get 23. So the other leg was 23. So we just found this to be 23. Okay? Okay, so let's scroll the page up, clear this out. We're going to scroll the page up and see if we can work on another problem. So another example says the hypotenuse of a right triangle. So again, I'm just going to slap a little example right triangle in here. Hypotenuse has a length of 12. One leg is 6. Find the length of the other leg. So we're going to do this exactly like we just did the last one, okay? So again, write down your formula. C squared equals A squared plus B squared, where C is your hypotenuse, so you plug in your 12, and then you plug in your legs for the other two sides, okay? 12 times 12 is 144. 6 times 6 is 36. And I'm trying to isolate the x squared term, so I'm going to have to get rid of the 36. So a positive 36 means I have to subtract 36. So they will cancel, and I will have x squared all by itself. 144 subtract 36 is 108. And then to undo a square, I have to square root both sides. So I have to do the square root of 108, and I have to do the square root of x squared. Again, inverses cancel, and x equals the square root of 108 is about 10.4. And then the last example, we have a right triangle. It has legs of 16 and 30 and a hypotenuse of 34. Do the lengths of the sides form a Pythagorean triple? So remember, the definition of the Pythagorean triple said that the numbers given, the three numbers given to you, would satisfy the equation. So we have to see, does it make this equation work or not? Okay? If it's true, so if they are equal, then the answer is yes. And if they're not equal, then the answer is going to be no. Okay? So let's see if it works. Let's plug in our hypotenuse. 34 squared equals first leg, 16 squared, plus the second leg. 30 squared. So 34 squared is 1,156. And I'm trying to decide, does this or does this not equal 16 squared plus 30 squared? Okay, so 1,156, let's see, does it equal? 16 squared is 256, and 30 squared is 900. And if I add those together, I get 1,156. So they do in fact equal each other, which means that these three numbers are in fact a Pythagorean triple. So your answer is yes, they do satisfy, the lengths do form a Pythagorean triple. So that is how to use the Pythagorean theorem and plug numbers into it to solve for missing side of a right triangle, and how to determine if three given lengths are actually a Pythagorean triple or not. The next video is going to talk about how to classify right triangles using the Pythagorean theorem, and it's also going to help you to solve some word problems.